This is Mrs. Cribb, and this is a video about the common errors from quiz 10. I'm going to go over some of the questions that were actually on the quiz, and hopefully you'll understand anything that you might have missed. First of all, there are a couple of questions about converting one pressure unit into a different pressure unit. So here's the pressure unit, 252.56 torr, and we want to convert to atmospheres. So 1 atmosphere then has to be on the top. So you see you need to write it out so you can see that the units are going to cancel. And then you need to look at your reference sheet. So let me pull up the reference sheet. And if you go up here, you see 1 atmosphere equals 760 torr. So that was the relationship we needed. 1 atmosphere equals 760 torr. So if the relationship is 1 atmosphere equals 760 torr, then you use this to create this conversion factor. 760 torr would go on the bottom. You cancel out the units and do the math. I'm going to do the math real quick. Let's see, 2.56 divided by 760. I get 0.00338. That's my raw number. I have to look at significant figures. First number has 3. Leading zeros are losers. 1, 2, 3. So I have to round to this spot. I look at the 8. The 8 causes the 6 to round up. So it's 0.00337 atmospheres. And you have to have typed in the unit, the correct unit. So make sure you type in the unit I asked for. Okay, some of the common errors for this one is instead of dividing, they multiply by 760 torr. Well, that's not going to work. Atmosphere is not going to cancel. It's not going to show up. Torr and torr can't cancel. So you end up with some weird number, and your unit would actually be torr squared over 1 atmosphere because nothing canceled. So make sure your units are canceling. It's the same kind of question for the next one, so I'm not going to go over that. But then here's this. This was a very common error. Express 4.78 kilopascals as pascals. First of all, kilo, like 1 kilogram is 1,000 grams. 1 kilometer is 1,000 meters. 1 kiloliter is 1,000 liters. 1 kilopascal is 1,000 pascals. And I know this was in the review for the, we did in class. I pointed it out to you in class, but it's also, I know it was in the review for the test. Some people used, however, the reference sheet, so I'm going to go back and look at that, and they said, okay, here we have pascals and kilopascals, and they read it as either 325 pascals is equal to 101.3 kilopascals, or they put 101.325 pascals equals 101.3 pascals. Really, the only difference between these two numbers is this is 101,325. There's no comma there because in Europe the comma is a decimal place, so there's just a space to space out the different places. So it's 101,325, not 101.325. It wouldn't make sense that 101.325 also equals 101.3 kilopascals. So this was actually a very easy question. If you wanted to use the reference chart, 101,325 pascals equals 1 kilopascal, that would have been okay. I mean, actually, it equals 101.3 kilopascals. See, this right here is like it's a missing comma, and it's there, not there on purpose. This would have worked and still given you the correct answer. It made no sense. I had a few people do this, and they had the final answer was 4.78 pascals. Well, that doesn't make any sense because kilopascals cannot equal pascals. This was the easiest relationship to use. All you had to do was 4.78 kilopascals, and there are 1,000 pascals in 1 kilopascal. This is just a metric prefix, kilo. The kilopascals cancel. So it's 4,780 pascals. This was the most correct answer. I took it, you know, I gave you partial credit if you did this. If you said, or I think I even gave you full credit, 101, let's see, 101, 325 pascals is 101.3 kilopascals. If you did that, you're still going to get a very similar answer. Let's see, that would have been 4.78 times 101,325. Sorry, try that again. 4.78 times 101,325 divided by 101.3, and I get 4,781.17, and then I would have to look at significant figures. 3 sig figs, 1, 2, 3 sig figs, so it rounds to 4,780 again. This 1 goes away, but you have to replace it with a 0 because that 8 has to stay in the tens place. So see, you would have gotten the same exact answer even if you used this relationship the same. But what I had trouble with is some people put a decimal place right there, and that doesn't make any sense. You cannot have 101 pascals equal 101 kilopascals. So be careful with the just plain old Greek prefixes. All right, the next one I'm going to work completely. This would have been a question where it's multiple questions because I asked you for which formula to use and stuff. So a sample of gas occupies 350 milliliters. So I'm going to write that down. Volume is 350 milliliters. When it's under a pressure of 1.35 atmospheres. Pressure 1.35 atmospheres. What volume, all right, that's a V2, will it occupy if the pressure is increased to 750 torr? This question will be used several times because I asked you what the formula was and what the final answer was. Okay, so the first thing you should have done is notice that sometimes it might have said the temperature is constant, or, well, if it says that it's constant, you don't need it in the formula. All you have that changes are 2 V's and 2 P's. So the formula is P1V1 equals P2V2. And then the next thing you had to do is make the pressure units match. And you could have changed atmospheres to torr or torrs to atmosphere. Either one is fine. So in this case, I'm going to change torr to atmosphere. So I would have had to say 750 torr, 1 atmosphere, and I would have to have looked on my reference chart to see the relationship. 1 atmosphere is 760 torr. So 760 torr. And so 750 divided by 760 is 0.9868, and I have to look at sig figs. 750 only has 2 significant figures, so 1, 2, so it's 0.99 atmospheres. Okay, so that means instead of using this number, I'm going to use 0.99 atmospheres. Okay? So now I'm going to put them into P1 and V1. So P1 is 1.35 atmospheres. V1 is 350 milliliters. P2 is 0.99 atmospheres. And V2 is the question. Now, let me point out something here. When you're doing this unit conversion, you do not use these significant figures. These are not significant figures. These are definitions. The significant figure comes from this value here, which is the measured value. So you had to have 2 sig figs. All right, now that we have this, we just divide both sides by 0.99 atmospheres. All right, that cancels out. So we have V2 all by itself. And now I'm going to pull up my calculator and show you this one. All right, so it's 1.35, backspace, 35 times 350 divided by 0.99. I get 477.27, and then I have to look at significant figures again. Okay, so this one only has 2 sig figs, 2 sig figs. This one has 3. So you take the smallest number, 2 sig figs. So I need 2 significant figures. The 7 looks at the next number, which causes that 7 to round up. So it's 480 milliliters. And that was the answer, 480 milliliters. All right, now let's go to the next question, which is, I'm going to do a couple more. So a gas has a volume. Now these are the exact questions from the quiz. So this is why I can't put this kind of thing up until everybody's done it. A gas has a volume of 85 milliliters and a pressure of 0.88 torr. What volume, V2, will the gas occupy if the pressure is increased to 1020 torr and the temperature remains constant? All right, if the temperature remains constant means I don't need to use it. I don't know what the temperature is. It's not 0 degrees Celsius. It's not 273 kelvins. It's not 20 degrees Celsius. I don't know what it is. It's just the same on both sides. So I can't use the temperature. I can only use the pressures and volumes again. So I'm using P1V1 equals P2V2 again. Okay? Now, if it only had pressures and temperatures, it would be P1 over T1 equals P2 over T2. If it only had volumes and temperatures, it would have done this law. And you needed to know what each one meant. This was Charles' law. And in Charles' law is what we had to know the name of it. And you could have written that on your 4x6 card for the test. This one is Gay-Lussac's law. And then again, we're using Boyle's law here. So P1 is 800 torr. V1 is 85 mils. P2, gosh, this one was even really very, see, it's simple. And then V2 is my volume. I didn't even have to convert anything. Let me make sure I didn't read that wrong. A gas has a volume of 85 milliliters at this pressure. So that's V1 and P1. So P1 is 800 torr and the volume is 85 mils. What volume will the gas occupy if the pressure is increased to 1020 torr? So this one's really easy. You didn't even have to convert. So we just have to divide both sides by 1020 torr. So what is the volume? Let's pull up the calculator and do it. We have 800 times 85 divided by 1020. And I get 66.667. Now notice something too. The pressures are both in torr. So that means I can leave it that. I don't have to convert it to atmospheres or anything else. I just need the pressures to be the same. Then we have to just change for sig figs, and it's only 2 significant figures in the number 85. There are 3 sig figs here, but there's only 2 here. So the answer has to be 2 significant figures. This number has 3 sig figs, because this 0 is not significant because there's no decimal. So 2 significant figures, 1, 2. So this causes me to look at that 6. It rounds to 67. 67 milliliters was the answer. Excuse me. All right. Now, by far, this was the most missed on the quiz. And I warned you about this one because of this. A sample of 32.0 milliliters of hydrogen, that's a volume, is, and here's the key, collected by water displacement, or collected over water at a temperature of 25 degrees C. The barometer reads 652 torr. That's a pressure. What is the volume at STP? Standard temperature and pressure. Okay, this is a temperature. And there's a volume, excuse me, and a pressure. And there's another volume, and this STP, that's another temperature and another pressure. So we have all 3 variables at play here, because it's asking me for V2. I give me V1. It gives me T1. T2 is standard. P1, well, this is actually the P total, but P2. So we have 2 V's, 2 P's, and 2 T's. So that has to be P1 V1 over T1 is P2 V2 over T2. I have to use the combined gas law. But that's not all. right, so what is, let's list everything. V1 was 32.0 milliliters. T1 was 25 degrees Celsius, but we always have to convert to kelvins. So we add 273 and we get 298 kelvins. This is the correct T1 now. It does have 3 significant figures, because when you're adding or subtracting, you look at place value. 25 degrees Celsius ends in the ones place, so it has to end in the ones place, the final answer. So now we use the T1 as 298 rather. Now P1 is a question mark. What I'm given is the total pressure, and I know that because it's by water displacement. This was the, pay attention, super important words that I told you about. So what it means is we actually have the total pressure, and we need the pressure of our gas, which in this case is hydrogen, plus the pressure of water is equal to the total pressure. The total pressure was 652. And I even asked you to go look up the vapor pressure, because the pressure of the water is the vapor pressure. I said, what is the vapor pressure in the quiz? And you had to go find it out. And I asked you for the vapor pressure in torr on purpose. And the reason I asked you for it in torr is because this was already in torr. Okay? So if the total pressure is in torr, I want to subtract out the vapor pressure in torr. So I had to go look the vapor pressure up. And this is where people kept messing up. Okay, so I'm going to pull up the reference chart again. Vapor pressure in torr. Well, first of all, notice this. 760 torr equals 760 millimeters of mercury. It's the exact same significant figures and exact same numbers. The only thing that's different is the unit. So this vapor pressure chart does not have torr, but it has millimeters of mercury. So I had to go down to 25 degrees Celsius and look at the millimeters of mercury, 24.0. I didn't have to convert to ATMs and then change it to torr. I didn't have to say at 25 degrees Celsius it's 3.2 kilopascals and change that to torr, or 3.032 ATMs and change that to torr. All you had to do was say 25 degrees Celsius is 24.0 millimeters of mercury. 24.0 millimeters of mercury is the same thing as 24.0 torr. So let me pull back up the sheet. I could have gotten from there that at 25 degrees Celsius, the vapor pressure, and I did ask you to give me the vapor pressure, was 24.0 millimeters of mercury, but I needed it in torr. So do you see that 760 torr is 760 millimeters of mercury? Notice that 760's cancel, millimeters of mercury cancel, so it's also 24.0 torr. This is the number you should use. This is the vapor pressure I asked for. All right, so then I asked for an adjusted pressure. Well, if this is the vapor pressure, the adjusted pressure is the pressure of the dry gas. This is the original pressure, 652, that you were given. That's not the one you're going to use. That's why I said give me the adjusted pressure. This is not the pressure you need. So then you take 652 minus 24 to give me, I think it's 628. Let's see, 652 minus 24 is, yeah, 628. 628 torr. This is P1. The significant figures have to end in the ones place because of that. So that's P1. Your P1 was 628 torr. People made this way more complicated. They went and they looked at the ATMs and then they converted it to torr, and which is way more work than you needed to do. Please, be very careful about that. Now, if you did that, I did try to follow your work. But the next thing was put it all in the P1 V1 over T1. So P1 now is 628 torr. I had a lot of people put 652 torr in that P1 spot. But 652 torr was the total pressure not the pressure of just the hydrogen. You had to do this adjusted pressure. That's what went there. So 628 torr is P1. V1 is 32.0 milliliters. T1 was 298 kelvins. Okay, what is V2? V2 is my question. What is T2 and P2? Well, T2 is standard temperature, so 273 kelvins. And P2 is standard pressure, and standard pressure is 760 torr. Now, how do I know that standard pressure is 760 torr? If I go back to my reference chart, 1 atm is standard pressure, but so is everything that it's equal to. So 760 torr is also standard pressure. So that means P2 is 760 torr. V2 is my unknown. And T2 is 273 kelvins. All right, if you did all that, if you got these numbers correct and you still got the wrong answer, I probably only took 1/4 of a point off. But you need to make sure you're cross multiplying and being very careful. So you cross multiply. So we say 628 torr times 32.0 milliliters times 273 kelvins equals, do the other side, those 298 kelvins times 760 torr times V2. And then I need to divide both sides so I can isolate my V2. So divide by 298 kelvins on both sides. 298 kelvins. And divide by 760 torr on both sides. All right. Now you can cancel those units so that V2 is all by itself. And then I'm just going to pull up the calculator and do the math. All right, so it'd be 628 times 32 times 273, enter, and then divide by 298 because it's on the bottom, and divide again by 760. There's no need to multiply everything at the top and write down a number and multiply everything at the bottom. Just do this. You get 24.22. 24.22. And then we always have to evaluate for significant figures. So 3 sig figs, 3 sig figs. Of course, that one doesn't matter because this one is the definition, so we don't count that one at all. We don't count the 760 torr because it's a definition. 3 sig figs, 3 sig figs, so 3 sig figs. So the right answer is 24.2 milliliters, 3 sig figs. So that question was missed a lot because, again, I gave you the clue, what is the water vapor pressure? And I asked you for the adjusted pressure. I was hoping that those words would be enough to remind you to subtract the water vapor from the total pressure because the water vapor was included with the gas and we needed it not to be included. Okay, that's, is that it? Yeah, that's it. I don't know why it disappeared like that, but okay. So that's all the common problems with Quiz 10. I hope you understand it, and I will see you soon.